All right, so your learning target for today is going to be I can estimate sums and differences of decimals by using rounding and compatible numbers. So you need to open up your math book to page 66, and I'm in the visual learning question. So if you take a look at the question, it says students are collecting dog food to give to an animal shelter. Estimate how many pounds were collected in week 3 and week 4. So in the top you have your data table where you have week 1 was 172.3, week 2 was 298, week 3 was 237 and a half. Week 4 was 345 and 1/10, and then week 5 was 338. So when I'm estimating how much I collected in those 2 weeks, the operations I'm going to be using is addition because I'm combining these two values, so I'm going to be using addition for that. So the first way that I'm going to show you guys how to use estimation is by rounding. So when I round, I use my rounding rules. So anything that's going to be greater than 5, I'm going to round up. Anything that's less than 5, I'm going to round down. So I'm going to round to the nearest whole number. When I round to the nearest whole number, that means I'm looking at this value right here. And I'm in the 7 and 237 and a half, and then the 5 and 345 and 1. When I look at that value, that's the number whether I'm going to round up or round down. In order to know whether I'm going to round up or round down, I then have to look to the digit to the right. So here I have 237, but I have a 5. My rounding rule says 5, or if it's greater than 5, I'm going to round up. So 237 and a half is going to be approximately 238. I'm going to do the same thing for 345 and 1/10. So I'm going to look one place value to the right. So I have a 5. I look one place value to the right. I have a 1. So it's going to be 345 and 1/10 is approximately going to be 345. Then what I'm going to do is I'm going to add those values. So I'm going to add 238 to 345, and that will tell me about how much I approximately collected in those 2 weeks. So when I do this, 8 and 5 is 13. I regroup the 1, 3, and 4 is going to be, I have 4 and 4, which makes 8. 2 and 3 is going to be 5. So they collected approximately 530 pounds of dog food. The second way that we're going to look at this is we're going to use a compatible number. A compatible number is going to be a value or a number that is near your original number. So what I have is I have 237 and a half, and a number that's going to be near 237 and a half that's going to be easy to add. Compatible numbers, I want them to be easy to add. That's going to be close to 250. And then I have 345 and 1/10, and that number is going to be close to 350. And so it's not rounding because the nearest whole number would have been rounded to 238, but it's a compatible. It's a number that's near that's going to be easy to add. So when I add these two values together, I'm going to get 600. So here I ended up with 600 pounds of food. So this method of rounding the compatible numbers is not going to be as close as when I round to the nearest whole number. Another compatible number that I could have used for 237 and a half was I could have done 240. That's a compatible number. So if I round to the nearest tens place, when I have a decimal, that would give me a compatible number. When I'm rounding to the nearest whole number, that is going to be rounding. Okay, so let's take a look. Let's flip to the next page. So we can also estimate differences, and I'm going to use the same two methods. I'm going to use rounding, and I'm going to use compatible numbers. So I have 22 and 8/10 subtract 13 and 9. I don't want to round after I find the sums and differences. When you get something that says estimate, you need to estimate before you do the operation, not after. Okay? You're putting yourself into too much work if you're doing the estimation after you've done the work. The estimation is a guide to help you to see whether or not you're close when you find your solution, whether or not you have an answer that is reasonable. So if I round, again, I'm looking over here, so I'm looking at my rounding. I underline my ones place value because that's the digit that I'm rounding. I look to the right, 22 and 8 tenths. 8 is greater than 5, so this becomes 23. And then I have 13 and 9 tenths. So again, I look to the right. 9 is greater than 5. So this rounds to 14. So my answer is going to be equals 9. So when I round, this little squiggly mark right here means approximately. This just needs to be straight. Is my answer is going to be approximately 9. Now, compatible numbers are going to look different. I want to find a 5 or a 10 that is near 22 and 8 tenths that's going to be easy to round. So in your book, they give you the example 20, or they give you the example 25. They did 25 because 22 and 8 tenths is going to be closer to 25 than 20. Either one of those is going to work. So I'm going to do 20. And then I'm going to subtract, and 13 and 9 tenths, that's close to 15. So my answer here is going to be 5. So when I do this, I get an approximate answer of 5. Now, this answer is a lot lower than this answer. Let's talk about why 5 is so much less than 9. Here, what I did when I had 22 and 8 tenths, I rounded up. Here, when I have 13 and 9 tenths, I rounded up to 14. So because I rounded both 23 and 14 up, I'm going to have an answer. So 9 is actually going to be greater than my actual sum. Here, so this is your actual sum. Whereas when I look here, I rounded down. I rounded 22 and 8 tenths down, but I rounded up here. But because I rounded down, and I rounded down a larger value, right? I went down 2 and 8 tenths. So that's a large amount. 13 and 9 tenths, I only went up 1 and 1 tenths to get to 15. So because the value that I rounded down was larger than the value I rounded up, my estimate is going to be less than my actual sum. So here on this one is going to be less than the actual, or not sum, actual difference. Apparently in my world, I was adding actual difference. Okay. All right. So let's take a look at a couple of examples. All right. So if I have, I'm going to jump over to number 49, or to number 3. So I'm going to do 49 added to 22 and 88 hundredths. So here, I'm actually going to use compatible numbers because this one is already rounded, but I want to make it easier to add. The goal of estimation is to make it easier to add. So I'm actually going to round 49. I'm going to make a compatible number of 50 because it's already rounded to the nearest whole number. And I'm going to take 22 and 88 hundredths, and I'm going to add that to 25. So when I add 50 and 25, my approximate answer is going to be 75. Now, when you are doing your estimation, what I want to see in terms of your work and your thinking is I want to see this. I want to see what values you used for your estimation. Okay, let's take a look at another one. So if I have 23 and 2 tenths, so I jumped over to number 6. I'm going to be number hopping to find one that I want to get practices on. So 23 and 2 tenths, subtract 9 and 71 hundredths. So when I do 23 and 2 tenths, subtract 9 and 71 hundredths, I'm going to go ahead and I'm going to round to the nearest whole number. So again, 23, I look at the 3, look next door. Oh, that is going to be a less than 5, so this is going to stay at 23. I'm going to look at the 9, Look next door. Oh, 7 is going to be greater. So 9 is going to round to 10. So 23 subtract 10 is going to be 13. So my answer is going to be near 13. Again, showing my thinking of what I rounded to. All right, let's take a look at number 7. We'll just go right to the next one. So I have 23 and 8 tenths, subtract 4 and 7 tenths. So again, I can do this one of two ways. I can look at rounding, and when I round, this would give me 24 because 3 would round up to 4 because this is greater than 5, and then this would round up to 5. So I could do 24 subtract 5, or if I wanted to make it easier, I could use a compatible number of 25 because 25 is near 23, and then I can subtract 5, and I get an answer of 5, which means my answer should be around 5. Okay. All right. Going to number 8, because I apparently have been doing lots of subtraction problems. I'm going to do 87 and 2 tenths added to 3 and 9 tenths. So when I look at this one, again, I'm going to go ahead and round on this one. So I'm going to underline my place value to help remind me. 7, look at the 2, that's less than 5, so this stays at 87. I'm going to add 3. I look next door, that's a 9, becomes a 4. This is equal to 91. So my answer should be around 91. Okay. My estimate, so this is my estimate. My estimate is actually going to be greater than the sum because I rounded 4, and then I rounded the 4 up, and then I rounded the 87 down. So it's going to be around 91, and it should be greater than, my estimate should be greater than the sum. All right, if we take a look, let me see where I'm at. 1, because I think this is an important thing, and I stated it earlier in the video, but I want you guys to have this down on paper. So when I look at this, it says in the example above, which estimate is closer to the actual difference? How can you tell without subtracting? So the estimate that I had when I rounded was about 9, and the estimate that I had when I used compatible numbers was 10. So I looked at what I rounded. So when I did 22 and 8 tenths, I rounded up to 23. Okay. And then when I did 13 and 9 tenths, I rounded up to 14. If I take a look at the 10, 22 and 8 tenths, I rounded up to 25. And then 13 and 9 tenths, I rounded up to 15. So it asked which one is going to be closer to your answer. The answer is going to be rounding. And the reason why rounding is going to be closer to your actual answer, and notice I did this without any addition and subtraction. It's going to be closer because I rounded to the nearest whole number. Rounding is going to be more exact. Because the rounded numbers are closer to the original numbers. Asked to find compatible numbers. You need to find a number that is going to be near the original. 5s and 10s make good compatible numbers because 5s and 10s are easy to add. When you're asked to estimate, you either need to use rounding or compatible numbers.